So I guess my presentation then sort of comes in at a time when I need to marinate the two and, make everything a bit more palatable for everyone. So I think my chart sits between the two extremes, where at one point we're looking at the legal stuff, and now we're going to take some time to look at the more generic application of these things in a specific area of future transport manufacturing. I must
Fantastic.
indicate that yes, I think when I got the NRF award nomination, I was with TUT. That's very correct. But currently, I've moved on. But I still do some stuff with TUT at the Industrial Engineering Department. But I take it that Dr. Nanzelele, who's currently taking care of some of the responsibilities that I was taking care of there, is also in the meeting, and he will maybe share his thoughts as well in the comments. So I'll just dive right in. I think a lot of introductions have been done about fourth industrial revolution and possibilities and all that. So I'm not going to go back to that. I'll just dive in straight into talking about. But maybe some people are asking why future transport manufacturing. I think particularly for South Africa and maybe the African continent at large, the fact of the matter is that we still do have huge transport problems, connecting people with places and making sure that people who are far away from the sources of income or the sources of health or the sources of family connection or the sources of education are able to connect with these places because essentially that's what transport does. But we take a step back and we say, okay, how are we actually producing? So it's manufacturing, but looking at how, we do this for the transport sector. And we've heard from the previous speakers that have spoken even yesterday about the way that this industrial revolution is changing our world. There's even talks about the fifth industrial revolution, and it's a fact. I think we need to accept this as another, maybe as a sixth finger on the hand, um, that technology and its evolution will continue to be with us, and we need to embrace it as our way of life. It mustn't be, yes, we speak about the future of this, the future of that, but the reality, if you also look at it, maybe that future that we're also thinking about, there are places in some corners of the world that is actually the reality as we speak. So there are several things areas that are reshaping the manufacturing world. There's the industrial Internet of Things, which is playing a huge part that plays 60% of the transformation that is taking place within the complex manufacturing field. We've got artificial intelligence, which is measured to be sitting at around 58%, and we've got automation and robotics, which is sitting at 46%. And we've got big data analytics, which is sitting at 38%. We've got additive manufacturing, which is speaks also to the topic that we just spoke to recently. And then we also have cloud computing. So as we think about the future of manufacturing, we will also take some time just to give some insights on what we're understanding, what we're seeing as we're doing research around this area. So in terms of the Internet of Things, I'm going to take some time just to speak about what happens at a machine level. So we have a prototype diagram here where I'm pointing of a machine that is supposed to be reconfigurable, but is able to bend parts, sheet metal, and is also at the same time able to press this sheet metal in a specific shape that is desired. So the machine itself, with all the subsystems of the machine, has sensors that are embedded in it to help us detect issues of likelihood of failure, but also issues of accuracy of the parts that are produced. So this information at that sensor level can then be taken to an AI system where it can be analyzed, and the physical device as well as the visual process can be observed these IoT devices allow us to be smarter in our production, to be more efficient. They also allow us to exchange data in real time. And because of the sensory devices that are put within these machine structures, we are able to predict the failure of the parts of the machine, but also we are able to predict the quality of the product that we're producing. As a result, optimize the performance of both the production system itself, but also of the components that we are speaking to or that we are producing in a specific process. And this also then ultimately then reduces the downtime that is associated with the production process. So IoT devices a very key role to play, but I must emphasize that as we think about these technologies, it's always important to realize that it's not technologies sitting there. And yes, we've classified them and defined them in specific areas, but you discover that these technologies also have an integration with other technologies. As we seek to understand one set of technologies, as we do that research, we also then realize that maybe we need to solve these problems, not maybe in the technology that we're really worried about, but maybe at another level of the technology. And then when it comes to the use of automation and artificial intelligence, so the previous slide also speaks a bit to that, but here what we're worried about is how do we enhance production efficiency? So for one of the projects that we are currently working on, when the production started off, part of it was done offshore as a way of initializing the production process. And then the rest of the majority of the parts were due to be produced locally. So there's a lot of skills transfers, a lot of new production systems that need to be developed. And with the localization agenda, then it also becomes important if we are going to compete at the pace at which the technology, the products were produced overseas, and compete as well at the level of the quality that the products were made overseas. We need to be able then here locally to develop some of these technologies, verify that they are indeed efficient and they're speaking to the performance at a global level as well as at a local level. But at the same time, our ideas, I will speak about supply chains later on, is to also pick up some of these guys who are doing well on these technologies and transform them into the industrialists of the future who are using these technologies and just not using the conventional production systems. And AI has a part to play, to be mentioned even throughout the other presentation slides that I'm going to be making in this presentation on how it's optimizing these processes at a machine level, how it's optimizing these processes at a device level, how it's optimizing these processes even at a system level where you've got machines producing a specific product or a specific part within a broader configuration, maybe of the production of an aircraft, like was presented in the previous slides. So these technologies collectively help with the productivity and the reduction of costs, but more importantly, especially touching on the people side, which speaks more to the rights of the people, ensuring that there is employee satisfaction that is generated in the process, because employees are able to do those jobs that are not hazardous, but that are also fulfilling in terms of work-life balance. In terms of the sustainability issues, yesterday there was a lot of talk about the renewable energy. So definitely the way that we are going about our production, we are sitting at a time when some of the markets that you want to sell your products in are not only interested in the the quality of the product, they're not only interested in the maybe the issues that have to do with the social dynamics around which your production takes place. I think recently in the news, we also heard about what was taking place in Russia, where young people were being taken to work in unacceptable conditions. So when we think about sustainability in transport manufacturing, we are looking at also those dynamics which also lean a lot on the legal issues associated with the implementation of technologies and development of products that are intensively technology developed from a manufacturing perspective. But at the back of our heads, what we're really concerned about is how people are able to connect with places, how people are able to connect with other people, and how people are able to connect with opportunities. But this needs to be done in an environmentally conscious context. And so we've got some work that we've also done around energy consumption, specifically for the automotive industry. And if you look at the graphs there in terms of the issues around the environment, um, you've got electricity generated, which is the blue line, and then you've got the carbon emissions, which is the orange line, and then you've got the energy consumed. So if you look specifically at the carbon emissions, they are directly related to the amount of energy that you generate. So as you do your production, in as much as we are worried about the product at the end, if it's a car that you're going to use on the roads and its impact on the environment, we are also living at a time when we're saying, as you produce these kinds of products, how environmentally friendly is that production? And of course, a case in point currently is the issue around advanced battery technology and renewable energy integration, which are very key areas of innovation to make sure that we are moving in sustainable ways, and we are also worried about future generations. There's some work that we've done with some of my PhD students and some of my past PhD students around additive manufacturing. And here we've got some work around optimizing the process window for production of aluminum and silicon 12 samples via the selective laser melting process. And our concerns there are, if we are able to define those windows for the production of these aluminum parts, which will also bring about the environmental the reduction in environmental impact of the transport system, if it's a bus or if it's a train, and if you're utilizing lightweight components and you're able to define those parameters where you can produce through additive manufacturing components that will be able to be utilized starting off maybe with the non-structural parts of the transport system, but then also going to ultimately the structural parts that are dependent on the structural integrity, then that will make a huge contribution when it comes to a sustainable future for the transport industry and how we move people. So we are worried about customized production. We're worried about reducing waste. We're worried about accelerating the time to market, because additive manufacturing also is able to produce components faster than would have normally produced those components. And like I indicated with the aluminum example, those components would have conventionally been produced using cast iron or produced using steel, which is far, far heavier compared to aluminum produced parts. So the light weighting of these components and also the production of more complex structures is an opportunity that additive manufacturing provides in this age of the fourth industrial revolution. And on the quality assurance side, in this work with one of my past doctoral students, what we focused on was the question of how are we able to, when we are printing, because one huge issue with additively manufactured parts is the issue of saying, how do you consistently produce parts that do not have the porousness that sometimes comes with these kinds of processes. And so here we utilized a convolutional neural network, which was able to, whilst we were printing, you are able then to take the pictures at each and every layer, whilst the material is being deposited layer by layer, take the pictures, which give you a sense of the defects that are being imposed on the components, even during production. And then through an AI algorithm, analyze that specific component and decide, even at the end of its production, that this component will have the integrity that we want or not have the integrity that we want. So as I indicated earlier on, as we are utilizing these additively manufactured processes, we also then realize that there is a part that AI needs to play for us to ultimately realize the sustainable production that we are interested in. And then there's another project where we're looking at the digitalization of supply chains. And in this work, we are looking at a rail car manufacturer, and for each of those cars that needs to produce, there's a million components, and these million components come from several suppliers. And the question here is, how do you ascertain that the production happens on time, irrespective of the fact that we want to have multiple suppliers? And from a socio-economic perspective as well, the idea is also that these suppliers also involve other small players in this production process, so that the issues of the Gini index through these kinds of production systems are addressed through real opportunities that are created for people to contribute to produce production of real components that can be used here locally, but also that can be used across the continent. So the important thing there for all the manufacturers is the visibility and the transparency, just to know where exactly the products that I need and the sub-components that I need and the other components that I need to produce my final product, where are they in production, where are they in transportation, and then the central manufacturer then is able to trace this distributed network of producers. So that also then becomes important at that level of manufacturing systems. And then the other side also, where we've also been doing some interesting work, is on the realities, whether it's augmented reality, whether it's virtual reality of production. And particularly here, what we're interested in is training young people even before they get to the work environment. Because when you train people, young people, when they get to the work environment, sometimes it disrupts the production, but there are also safety issues associated with that kind of training. But with the technology that we have, particularly the virtual reality technologies, the augmented reality technologies, we are able to reproduce those realities in a safe context. To underline that as we think about these other realities, it's important to emphasize that these realities do not necessarily imply that we eliminate the physical training of the individuals, but we still need to go ahead and do the physical training of the individuals. But this will have already been improved through this design optimization that takes place here, and it will assist with the quality control of the training, the quality control of the production of the parts, the quality control even in the actual production environment ultimately, and the rate at which these young people, or the rate at which these new workers, because this is not just for students, these virtual reality environments, but as manufacturing processes transform from one manufacturing process to the next, then we are able to demonstrate that there is as we transform from one manufacturing process to the next, then we're able to then ensure that those people who are participating in this transformation of manufacturing processes can have a visual setup where they can be trained to be prepared for the next level of technologies, even before those technologies are live, or even while we're still doing permutations on how these technologies need to be configured. And then the last bit that I want to conclude on, you realize that, I mean, I haven't mentioned half the technologies that our sub teams work on at the industrial engineering department around this chair, but already there are so many of these technologies, and there is a lot of interlinkages between them. So what we also have is a gamified learning platform that helps then people to connect the technologies. And because it's gamified learning, it's more fun approach to learning than the conventional sit behind the chair, sit at the desk and look at the lecturer in the front. But the lecturer also gets involved in the gamified learning. It doesn't have to be a student lecturer set up. It could be an industry expert who seeks to introduce new technologies within their specific industry, and then they work closely with this gamified learning approach and the experts that we have in our team, to then look at what are the digital growth implications for the enterprise that you're running, what are the sustainable premise production issues in transport manufacturing for our instance, but this could be in any instance. It could be even in a service instance where you're saying you want to introduce new technologies to help you with your efficiency in your services and help you with the quality of the service that you're producing and help you with the reduction of the cost and optimizing the output of what you're expecting in your production. And in that regard, then this brings various teams which are configured as a company, and it gives people a sense of how these performances will transform with time as you apply specific technologies, but also how these technologies are linked to other technologies. And ultimately, as Marisha indicated earlier on with respect to the law issues, there's the employee satisfaction side in the digital age. So this gamified learning just doesn't focus on the technology and the hardcore issues of what kind of robotic tools are we using here, how well are the robotic tools able to perform, but it's also quick to be human-centered so that because ultimately enterprises, yes, they exist to make products and codes, but actually they exist to serve humanity. And it's important for us to be asking those questions of saying, what are the social dynamics around these things that we're implementing and ultimately the productivity that we want to be getting. So in a nutshell, my conclusion is that the fourth industrial revolution is driving the transport manufacturing sector to a new era of marked with connectivity, sustainability, and digital innovation. And definitely, gamified learning is a key enabler to people understanding what is taking place in this sector. But I also underline that this gamified learning approach can be utilized in other contexts that are not necessarily transport manufacturing. These trends are not only transforming how vehicles are being produced, right, but they are also shaping the future of transport, paving the way for more efficient, sustainable, and intelligent solutions. As manufacturers embrace these changes, they are better positioned to meet the evolving demands of the global market. With those words, I hope some insights and a sense of what is possible in terms of future transport manufacturing, but also in terms of our broader application of these technologies can have for us in the now and in the future. Thank you very much. I hope I have kept to the time. Yancy?
You have indeed. You have indeed, Prof Mpofu. Thank you very much for your interesting presentation, and you have pitched it perfectly in between the two first presenters. I also am very glad to get your perspective on manufacturing and the ways in which people are trained to in the manufacturing space. It's good to hear about things advancing, because in 2019, I think we had a discussion forum on the skills needed in the fourth industrial revolution, and there was something about virtual training, but not very much, and I think it was only one company doing it. And now this is to see this happening at TUT is very heartening. Is it only at TUT, or is it at Solusi University as well?
So this specific work that I'm speaking about here is taking place at TUT. So obviously we are also building up on these experiences to configure some work that is more broader continent at this stage, but currently the work is taking place at TUT.
Okay.
Yes.
No, very good to hear that. Thank you very much indeed. I'm going to move on. I don't see any questions as such, but please, attendees, if you have questions, do post them in the Q&A, and hopefully Professor Mpofu can answer them directly. Thanks very much, Prof Mpofu.
I see there's a question here. There's quite an interesting presentation. The future looks brilliant. The question is, how best can these innovations be put into reality? So I must also underline that I think what is interesting for us, maybe you heard also in the introduction that we're also running an incubator at TUT. So we have been deliberate about how we are connecting our research to what is actually happening in the industry. So up and about the Future Transport Chair, the Industrial Engineering Department hosts a Gibela Research Chair, and this is an industry chair. So Gibela is currently working on renewing the fleet for trains on the commuter rail infrastructure that is there in the country. So as we speak about these technologies, even those case studies that I was making reference to are case studies that are actually in collaboration with industry. So we are solving real industrial challenges. As we develop the cases, we're applying our thinking to real companies that are existing. So it's not just theoretical work. Yes, some of the models maybe looked a bit theoretical, but some of those structures, after they've been prototyped, they are being utilized by either SMMEs who are incubated, and the goal with those SMMEs is that then they then participate in the real economy that is associated with the industry. So the chair is grounded in being practical, and this is why there's an incubator associated with the work that we're doing at TUT. Thank you.
Fantastic. Thank you very much, Prof.